Now I'm sure you're going to decrease the number of questions you give us.
Not many questions I put there. Are there a lot of questions?
30.
Questions. But there are a lot of series, right?
Yeah.
Oh yeah, you got to get your hand around these series. I'm sorry. You have to. You can't do the looking at somebody else do it. So that means 2 problems a day. You've got 15 days. 2 problems a day. Right, you're unfair in this house. Yes. Yes. Weird, huh? Yes. For this particular function. For the other functions, see, for different functions. So we saw the other function, it was 1 and 2 and 3 and 4, and for E it was 1 and then 1 half and then 1 sixth and then 1 4 and 1 over. You see? Different functions with different numbers. Oh, no, I'm sorry, you're right. No. Yes, it depends what the value of the function is. Let's see if I said it.
2 minus 6.
Correct. If I said like this function here, and x equals 0. Well, you know, at x equals 0, what is the value of the function? 2. Right? Right. So it depends on the value of the function. Well, you're correct. The a is the value of the function at 0. Or whatever the value of the function is.
Yeah, 8 is.
So we all agree A was 1. What is B?
1.
B was 1, yes. C was 1, yes. D was 1, yes. E is 1, yes. F.
1.
Well, this is a very strange function. The coefficients are all 1. The only function for which the coefficients are all 1. Well, let me do it very quickly. So we'll put x equal to 0 here. So when we put x equal to 0, we're going to get a here, and we're going to get 1 here. A is 1. Now let's differentiate. What's the derivative of this? Negative 1 times 1 minus x is negative 2, and the derivative of negative x is negative 1, so it becomes plus 1. What's the derivative of this? B plus 2cx plus 3dx cubed plus 4ex plus 4ex cubed plus 5fx to the 4 plus 6 gx to the 5 plus 7 hx to the 6. So plug in 0. What do we get here? 0, 0, 0, 0, 0, 0, b is equal to, or 0 here? 1. Okay, let's differentiate again. What's the derivative of this? Negative 2, 1 minus x to the negative 3, derivative of negative x? Cancels with that. Derivative of this? 2c plus 3 times 2 dx plus 4 times 3 ex squared plus 5 times 4 fx cubed plus 6 times 5 dx to the 4 plus 7 times 6 hx to the 5. Plug in 0 on both sides. What do we get here? 2. And what do we get here? So C is 1. Okay, let's differentiate again. We have minus 3 times 2 times 1 minus x to the negative 4. Derivative of negative x is negative 1. What's the derivative of this? 0. 3 times 2d plus 4 times 3 times 2ex plus 5 times 4 times 3 fx squared plus 6 times 5 times 4 gx cubed plus 7 times 6 times 5 hx to the 4. Plug in 0 here. 3 times 2. Plug in 0 here, 0, 0, 0, 0. 3 times 2D. What is D? D is 1. Let me do one more. Differentiate this. Negative 4 times 3 times 2 times 1 minus x to the negative 5 times the derivative of negative x, which is negative 1 times 0. 4 times 3 times 2e plus 5 times 4 times 3 times 2fx plus 6 times 5 times 4 times 3 gx squared plus 7 times 6 times 5 times 4 cubed. Plug in 0 here, what do we get? 4 times 3 is 24. 4 times 3 times 2. And 0 here, what do we get? 4, this will be 0, that will be 0, that will be 0. This 4 times 3 times 2 times E. So what is E? E is 1. And this is going to keep going, keep going. E is going to be 1. So 1 plus x approximately 1 plus x squared plus x cubed plus x to the 4 plus x to the 5 plus x to the 6. That is the approximation. Let's see. Look at it. You can't distinguish the two here. Ms. Yasmina, if I want to make this equal, what do I do?
So, in try to lose accuracy at x equals 7, right?
X equal to 1. Very good question. Why is it not approximating at x equal to 1? Correct. The answer, this series is not going to converge. Ooh, converge. We have to know whether it's converge to this. That is to say, we have to do some convergence tests. Huh? It's not going to converge when x is 1. Oh, of course it's not! When x is 1, the bets are off. Don't even try it. That is to say, don't put 1 here. 1 plus 1 plus 1 plus 1 plus 1 plus 1 is 1 over 0. When is this true? The answer is x has to be between 1 and minus 1. I'll have to prove it. Have a good weekend.